We've got 6 quadric surfaces. Every time I say the word quadric, I want to say quadratic. No, it's quadric. There's one called an ellipsoid. Okay, remember the other day I taught you how to draw a sphere? You draw a circle, an equator, and a prime meridian, right? Not the best sphere I've ever drawn, but I think it gets across the idea. So what is an ellipsoid? An ellipsoid, you stretch it out one way or another or multiple ways. And you get, okay, for a sphere, you get cross sections that are circles. For an ellipsoid, you get cross sections that aren't necessarily circles, they are ellipses, right? So it looks like an egg shape, football shape. And when I say the cross sections, we're talking about a cross section created by a vertical plane or a horizontal plane. So how do you draw it? And you usually do want to draw it first before you put in your coordinate axes. So I don't know how well I can draw on this thing, but let's give it a shot. So in the plane of the screen, this is supposed to be an oval shape. And then I'll put in my equator. If this were kind of an egg shape and you cut it with a horizontal plane, this would be the trace, this equator would be the trace that results. And then if you cut it with a vertical plane through the middle, that is, you would get maybe like a prime meridian. Like that. And then if you wanted to coordinatize it, the origin's going to be right in the middle. That's what that dot is right there. So if you wanted to coordinatize it later on, you could draw in a vertical z-axis and perhaps a y-axis. So here's what you could do. I won't do this for all of these, but like that's your z-axis. And I'll make this guy my y-axis. And then the axis coming out at you, you have to imagine that coming out of the screen at you, that would be the positive x-axis. So you can coordinatize after you draw the picture with a lot of these quadric surfaces, and that's the easier way to draw it, okay? Rather than using the trace, rather than picking a trace and drawing that trace on a piece of graph paper, on a coordinatized piece of paper, put in the coordinates, put in the coordinate axes later, put them in after. And that's for me and for most people, that's the easiest way to do it. What kind of equation would that have? Well, the equation we would use is something like this: x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. And you can see if you let z or x or y be a constant, as long as it's not a constant bigger than 1 after you plug it in and square it, and divide by either a squared, b squared, or c squared. If you let x, y, or z be a constant, then the resulting trace, so for instance, if you let z be the constant 0, you're not always going to use 0 as your constant, but in this case it's convenient. If you let z equal 0, that is the xy plane, right? So this whole thing zeroes out, and the resulting trace is that equator I was talking about. Okay, and this would be the equation x squared plus y squared, x squared divided by a squared plus y squared divided by b squared equals 1 would be the equation of that trace in the xy plane. Does that make sense? Okay. All right, so onward and upward, the elliptic paraboloid. So if you see the part with the oid on the end, 2 of the traces will correspond with the part with the oid. So this says paraboloid. So you can expect 2 traces to be parabolas, okay? The other one, ellipsoid, you didn't see anything in front of that, so you can expect all the traces to be ellipses. But with an elliptic paraboloid, you can expect 2, because the oid is attached to the parabo part, you can expect 2 of the traces to be parabolas. and one of the traces to be an ellipse, an elliptic paraboloid. So if you can remember the name or recognize the name, it can remind you of what the object looks like. And this object will kind of look like a satellite dish. So if you want to draw it free, kind of an elongated satellite dish. If you want to draw it freehand, I usually draw the ellipse trace first. And then so this is assuming it opens upward. It doesn't have to. And then one of the parabolic traces, the one in the screen, the plane of the screen, I usually draw next. And then this guy down here is going to be the vertex, which is going to be at the origin. And you could also draw in the trace that would result from cutting this thing with the XZ plane right down the middle. So this trace right here would be another parabolic trace. And so this version of it, now you could put this thing on its side, you could make it open upside down, but it changes the equation a little bit. This version of it would have this sort of equation. Z equals x squared over a squared plus y squared over b squared. So what is the height of this trace, this elliptical trace? It's whatever you want it to be, because it opens up, it doesn't stop there. It opens up forever and ever and ever. But if, for example, you got to pick a place to cut it off when you draw this thing. So let's say I pick a height of z equals 1. Well, z equals 1 is really a plane then. And what we're really drawing when I draw this ellipse is where the plane z equals 1 cuts off the shape, because the paraboloid keeps going up way past this trace right here that I drew. Well, it keeps going up. And we could have cut it off up here. But then the question becomes, well, where do you cut it off at? Well, you got to cut it off somewhere. So we cut it off. I cut it off, and let's say for the sake of argument, I cut it off as z equals a height of 1. And then you can immediately see, if z equals a height of 1, what's the equation of this elliptical trace? It's this guy. 1 equals x squared over a squared plus y squared over b squared. I'll say more about that later on. We're going to graph a particular example later on. Question?
How do you find where it's minimum?
Well, it's the way we're drawing it, it's going to be at the origin. In other words, we would call that thing the vertex, and it's going to be at the origin. And how could you tell? Well, think about it. If, say, for the sake of argument, that this is the y-axis, and this is the x-axis, positive x-axis, then if you let x equals, say, 0, if you let x equals 0, you'd end up with this trace. Does everybody see why? Whatever that is. If you let x equals 0, this guy's gone, right? 0 squared divided by a squared is still 0. So the equation of that trace then is z equals y squared divided by b squared. And of course, that's just a parabola in the YZ plane, in the plane of the screen, right? And that's the form of a parabola that has vertex 0, 0. So it becomes pretty clear then that the vertex has to be here. You could do something similar by letting x equal 0, and then you'd have z equals x squared divided by a squared, and then this guy would be the one that zeroes out. So you can come up with the equations of those traces pretty easily. Again, I'll say more about that in a little while. So I'm just giving you one possible picture here for an elliptic paraboloid, but there are others.
Whatever it equals to, that's what's going to be.
Well, whatever's to the first power, then that's going to correspond to the axis that runs through the middle of the thing.